One of the moments that I remember very clearly as sparking my passion for astronomy was my first time going to a really giant telescope. The telescope was located on top of a volcano in the middle of the Atlantic Ocean, and to get there we had to take a long taxi drive up the mountain through the clouds, and at some point we turned a corner and the clouds parted, and in front of me was the largest telescope that I'd ever seen, and that's what I was going to use that night for my research. And I think that really stuck out to me as a moment where I thought this job is really cool. Hi, I'm Richard McDermid. I'm a Professor of Astrophysics at Macquarie University, and I'm the Project Scientist for MAVIS. What got me interested in research was actually first a fascination with the universe at large. I was driven by questions like, where do we come from? Where does the universe come from? Why are the stars in the sky? And these big questions, the only subject that could really help me address those was to go and study astrophysics at university. My particular field of research looks at galaxies beyond the Milky Way. And I look at the stars and the gas in those galaxies and look at how it's moving, look at its chemistry, and use that as clues to unpick the puzzle of how they got there. One of the key projects that I'm working on right now is designing and building an instrument called MAVIS. MAVIS stands for the Multi-Conjugate Adaptive Optics Assisted Visible Imager and Spectrograph, so you can see why we called it MAVIS. Earth's atmosphere blurs the images that astronomers can take. It's a bit like looking down to the bottom of a swimming pool and seeing that everything is a bit distorted and blurred. That same effect happens when we look out into space from Earth. Adaptive optics is a technology that allows us to correct for that effect, giving us beautiful, crisp, clear images and actually revealing new information that we otherwise couldn't access. And a major part of that is done right here at Macquarie University, together with many partners in Europe and other parts of the world. In the end, this instrument will go onto a giant telescope located in the Chilean Andes and work together with a complex laser system in order to correct for the blurring effects of the Earth's atmosphere. The biggest highlight for me in doing research is actually enabling the research of others. In particular, I supervise groups of PhD students who are just starting their journey into research as a potential career, and helping them realize those goals and at the same time making new contributions to science, I find personally really rewarding. At Macquarie University, our research informs our teaching at every step. We make use of professional level facilities in order to do our astronomy teaching, and we're fortunate enough to have such a facility right here on our own campus. Throughout the course, we try to give our students exposure to working with professional level tools that they would use, for example, in research. And in doing so, we train them in skills that they can use in other areas. My advice to students would be get engaged. Get engaged with your fellow students. There's lots of student societies, both in your discipline and beyond, and that adds a whole other dimension to your studies and might open opportunities that you hadn't thought of. I'd also say get engaged with your teaching staff in your department or your school or your faculty. Our teaching staff love interacting with students, and those interactions can often lead to new things. For example, we offer research scholarships to our students between second and third year that really enriches their studies and lets them participate in new research projects over the summer.